From this video, we want to find the values of x and then as well as the angle QRX to the nearest degree, and then the length, the distance of what P to Q. If you are new here, you make sure that you stay to the end of the video if you don't understand anything, if this is what you want to have a clear understanding. But if you're already on this channel, you know that we posted some of the short videos on how to tackle this problem. So this is the full video, so stay here to the end so that you don't miss anything. Now this is the diagram that we are given, right? So a very beautiful diagram here, not drawn to scale, but here's the what a scan or the full question in what a printed form. So perfect. Now your first step in tackling this particular question here is to gather all the information that are given to you. Those are going to be your building block. So what I mean by the building block here, that should be your starting point. So what are the information that we have? We have this angle here, PQR. So remember, the angle is always at the middle here, so PQR, right? So that is going to be equal to PSQ. So that is PSQ, meaning that the angle here, right? So you can see this symbol here. So this particular angle here is 90 degrees, and then the angle here is also 90 degrees. That is exactly what this information is saying. So where are we going to use that? So stay here for a second. So we have this line here, P to S. So we have P to S here, that is the 9 centimeters, and then we have this S to R to be also 16 centimeters, right? So these are all the information that we have been given. So how do you tackle a problem? By finding the values of the X here. What will be your first step here? Now the first step in solving this particular problem here, so this should be my solution here, so is to base on the information that we have. So here we can pick how many triangles that we are having. We have two different triangles. So this is triangle 1 and then this triangle 2, assuming. Is that okay? So assuming, so from this particular triangle, you make sure that you stay that, right? So from triangle, or you can use the symbol. Is that okay? From triangle, you have PQS, right? So from PQS, is that okay? So by using the Pythagoras theorem. Why are we using the Pythagoras theorem? Because we know that this triangle is what a right angle triangle, because one side of it is what a 90 degrees. If this is 90 degrees, it means that here is also 90 degrees, because angle on the straight line add up to 180 degrees, right? Okay, so since one side is 90 degrees, even we are told that PSQ is the same as this particular angle, tells you that here is also a 90 degrees, right? So that is why it's very, very important to gather information. Okay, since this is what a 90 degrees here, we can use the Pythagoras theorem. That says that the hypotenuse in the longest side here, so you may replace that by some small letters, but here let's use the letters that we have been given. So from this, or from the Pythagoras theorem, you have the length of PQ square, which is the longest side. You see, if I redraw this particular thing, the diagram should look like this, should look like something like this, right? And then here is 90 degrees. Is that okay? So here is going, this point here is going to be the longest side, which is going to be the hypotenuse. So the hypotenuse here, we have the hypotenuse is equal to the adjacent and the opposite square. So here, if you are here, the angle, you see, if you are here, that is how it goes. So here is going to be your opposite, which is the x. So before that, let's focus on this thing. So we have our length of qx squared plus what? PS square. We are not using anything new here other than use the Pythagoras. So that says that the hypotenuse square is equal to the adjacent square plus the opposite square, right? Okay, now we don't know the values of this P to Q here because we are not given the P to Q from the question. So here we maintain this one as it is, PQ square, that is going to be QS. Do you have QS? QS, that is the X here. So you are having the x square plus this guy here, px. So ps is 9 squared, so we have 9 squared, that should be 81, right? Okay, so here I can clean this one to be 81. All right, so let's leave it as it is because we don't want to proceed, right? So there's nothing we can do here again. You know, remember we are looking for the values of the x. That is what the question says. So find the values of the x, right? So here we have two people that are missing. So let's leave this one as it is and go on for the second triangle and see if that can help us to arrive at the values of the x here. And so solving from the second triangle, remember these 2 and 1 are not part of the question. It's you and I that brought this particular number just to differentiate, right? So solving from this triangle, I can use this notation. Okay, so this is a triangle notation. From triangle, let's say QRS, right? So from this triangle QRS, this is also a right angle triangle. You agree, right? This particular side is what a right angle triangle. So still with the Pythagoras theorem, so this is going to be the hypotenuse, the longest side. That is the length of QR square. It's going to be the adjacent square. Here I can use the x square and then plus the down here, right? So which is the SR square, which is 16. So that's going to be 16 square. Of course, 16 square should be 256, right? So 256. Do you agree? So if you don't know where these numbers are coming from, so just make sure that you comment along for us to attend to you very fast. Okay, now what are you going to do from this particular point here? So now that we are clear with this guy here, and then we are clear with this guy here, so that is why it's very important for you to gather all the information that have been given to you. So we can see that this is the combination of 3 different right angle triangles. So what I mean by that, this is one right angle triangle, and this is the second, and everything together is also what a right angle triangle based on this particular notation, right? So that is what the question was telling us from the information that we had. So let me maintain, because of a space here, let me maintain this guy. You have this and then this, so I can keep, let me keep them here. So I have q square, and that is equal to s squared plus what 81, right? So that I can easily wipe this space here, right? Okay, so here from this, the whole triangle, right? So that is a q PR, right? So QPR, or maybe PQR, right? So maybe let's in alphabetical, so that should be PQR, right? From the whole triangle here. So that is a right angle triangle because of this notation once again. So here we are going to use the hypotenuse. So you can redraw this and to see exactly what you are trying to say. So this is the picture. So if I redraw this thing like this, the 90 degrees is formed at Q, right? So from Q to R, and then here we have P somewhere here. So P is at the top and then Q is here. So this is at 90 degrees. Is that okay? So which side is going to be the hypotenuse? Of course, the longest side, right? This one should be R, right? So this should be R. The longest side is going to be the hypotenuse. So here we have our hypotenuse here. So are you okay? So you can always redraw this in for a better or clear understanding. So the hypotenuse, that's the P, the length of PR squared, that is going to be the adjacent and then plus the opposite. So that is going to be QR square plus PQ square. So everything here goes down to the Pythagoras theorem. Is that okay? So now this is where we need these two people information. We have the QR squared to be equal to this, and then we have the PQ also to be equal to this. So what is the values of this here? So P to R here, so P to R here, that is going to be 9 plus 16. Can you see? So P to R here is 9 plus 16. So 9 plus 16, that should be 25. So we have 25 squared, right? So that's going to be Q to R. Q to R here, that is the x squared plus 256. Is that okay? I'm just using this information here, right? Okay, so everything plus PQ. So PQ square, right? So PQ square, that's the x square plus 81. So that's x square and then plus 81, right? So here we are just going to do some simple additions. So we have 25 square, that is 625. Right there. So here we have x square, that's going to be 2x squared right? So perfect. So this plus this one, that should be, I don't know if you have any mistake here, so let me know if there's an issue with this particular additions. Is that okay? All right, so perfect. Now what next? So at this point, I believe everybody, almost everybody, can solve this instead. So here we are going to group like 10. So that's the 265, and then one is 337. That is equal to 2x squared. Right? So here subtract this by this and just find the values of the x. Let me know the values of the x in the comment section below. So that tells me that you are also watching or you are participating in this particular video. Now someone did a very great thing in our comment section, so congratulations. Right, I wish I can mention your name here. So the person was so smart in such a way that by saying that since these three triangles here, so this is one triangle, this is two triangle, and everything becomes a third triangle, are similar, so that the similarity is coming from everything is 90 degrees, 90 degrees, 90 degrees. The person was so smart to have that should be 12 cents, just cm. Right, if you agree, let me know in the comment section below. But if you don't agree, let's hear your answer so that we can learn exactly how to approach questions like this. So the second and the third part of this question says I should find the angle QRS. So angle QRX. So this particular angle here. So let's replace that by theta. You see, what are we going to use in solving this particular angle? Since this is a right angle triangle, we can use the word SOHCAHTOA. So that's the definition. So out of the SOHCAHTOA, so out of this, which one are we going to use here? So this is where we are. We know this from the first part of the question, and then we know this one. So if I'm here, this is going to be my opposite, and then this is going to be my adjacent, right? So perfect. So mean that we are going for tan. So tan theta, that is going to be equal to opposite, and then divided by what? Adjacent. So what is going to be our opposite? Our opposite here is going to be the x. So if you are here, this is opposite, right? So the x and then divided by the adjacent, and that's equal to 16. So this one requires you to find the values of the x before you can proceed to this point. That is why it's also needed for you to solve this third part of the question. That says that you should find the length p to q. So p to q here. Okay, if you want us to solve this particular problem, just comment yes in the comment section below. Is that okay? If you are unable to solve this problem, let me know in the comment section. If you are new here and then you get value from this video, make sure that you give us a thumbs up and then subscribe to the channel for content like this. If you're already here too, just make sure that you smash that like button and then comment if you have any special question for us. So thank you for watching.